Welcome everybody, this is Mr. Dean. It's Pre-Calc Boot Camp. We're going to be talking about some random topics that will be important in pre-calculus that will come up here and there. And the pre-calculus curriculum and textbook assume that you've already been exposed to this stuff and you know it pretty well. But we're going to go over it one more time to loosen off some of those cobwebs you might have about certain topics. So we're going to start off with simplifying roots. Multiplying square roots, still pretty easy. Root 2 times root 3 is root 6. You can just multiply them together. But as you see next door, root 2 plus root 3, there's nothing we can do. They're not like terms. It is simplified just the way it is. If you have a more complicated problem, like what's in red, we got the square root of 4x times the square root of 3 times x to the 4th power. There's a couple ways of doing this. One way is just to bring everything together and remove that and say that square root of 4 times 3 times x to the 4. All what's in the red can come together under one square root. We know the square root of 4 is 2. And we know the square root of x to the 4th is x squared. That's going to come outside of the square root, leaving behind 3x under the square root. And that is simplified all the way. Moving on to the next topic, rational numbers. The definition of that is basically any number that can be expressed as a fraction. An example of rational numbers are 0. 0 can be expressed as a fraction. 0 over 1. 7 can be expressed as a fraction, -2, decimals, so on and so forth. Negative numbers, those are rational numbers. Some square roots are rational. Square root of 16 is 4, it's a rational number. And squeezed in down here is the square root, the 0.3 repeating. And that is a rational number because that's equivalent to 1/3. If it can be written as a fraction, it's a rational number. Now, hypasis, or I believe it's pronounced hypasis, is one of Pythagoras' followers. He was a Pythagorean, and he is sort of credited with discovering irrational numbers. Examples of irrational numbers, square root of 2, square root of 3, and even numbers like pi, numbers that cannot be expressed as fractions. And a real simple way of thinking about it is you take a triangle, one side of the triangle is equal to 1 length. It's a right triangle. It's a 45-degree triangle. The other side is 1 also. And that means this hypotenuse, according to Pythagorean himself, Pythagoras, it's square root of 2. Square root of 2 is an irrational number because it cannot be expressed as a fraction. In fact, irrational numbers cannot be expressed as a decimal unless it goes on forever and doesn't repeat. So mathematicians agree on a certain format of writing fractions, and that is the denominator of a fraction cannot have an irrational number in it. So we're going to do a process right now called rationalizing the denominator. We're going to take 1 over root 2, example 1 here. The way to do it is to multiply it by root 2 over 2. What that does is you're multiplying by a value of 1. You're not really changing the value, how much 1 over root 2 is. But you're changing the way it's expressed. Now that we multiply straight across, we end up with the root 2 over root 4, which is equal to our final answer, root 2 over 2. Example 2, down the bottom here. We're going to multiply by what's giving us trouble. The trouble in this problem is the root 3 is in the denominator. We can't have that. So we're going to multiply by root 3 times root 3, root 3 over root 3, sorry. And we get a final answer, multiplying all the way through, canceling out the 3's, of root 6 over 2. Dividing fractions, next topic. What's 12 divided by 1/3? For many people, they would think that it is 4. Does not. If you had, for example, a pizza, and you had 12 slices of pizza, let's see, that's 8, that's 10, 12, and each of these slices was cut further into thirds somehow. I can't do it very accurately on this, but you'd end up with 36 pieces of pizza if you cut all these into thirds. Well, it turns out it's true. 12 divided by 1/3 is 36. And what's the deal with that? Well, underneath here it says, quote, for myself, I'm quoting myself, you are not to reason why, just invert and multiply. I didn't invent that quote, but I said it once. Here's how it works for something more complicated like example 2, 5/8 divided by 3/4. You are not to reason why, just take the reciprocal of the second fraction, the denominator's fraction, take the reciprocal of it and multiply instead of divide. Once you do that, you can forget about the fraction of the denominator. You can kind of cross-cancel these numbers and multiply straight across. 5, 6. So if we do that back in example 1, see if we get 36. We will get 12, but now we'll multiply it by the reciprocal of 1/3, 3/1. And sure enough, we do get 36. So that's how to handle fractions and dividing by fractions. We see that a lot in pre-calc. Reducing fractions or simplifying fractions. Just a review. Zeros can cross-cancel or just kind of reduce like that. And you think about what goes into numerator and denominator. The greatest common factor is 9, leaving us 3/4. In example 2, there's a pi hanging out, and we'll find out that in pre-calc we leave pi in terms of pi. We don't multiply it out by 3.14 very often. There'll be maybe a case here and there. So we're just going to take care of the numbers part of it and leave pi alone. And we got 1/6 times pi. In pre-calc and calc, you'll find that we almost always write it, instead of 1/6 pi, we'll write it like this, pi over 6, but it has the same meaning. Example 3, down below. Just wanted to see if we could handle a large fraction. All right. So if we had to simplify this fraction, I can put it into my calculator. I can go into math, and you'll see right away the very first button under the math catalog is frac. And I just have to hit enter after I do that. Hit it twice, I guess. And our simplified fraction is there. 2388 over 101. 1001. So your calculator can simplify all your fractions for you if you didn't know that already. All right, last topic in our frenzied pace of pre-calc boot camp, solving quadratic equations. A couple of ways to do these. The easiest way on this particular one is to factor. If set equal to 0, we're going to factor x squared minus 4x plus 3. If you remember factoring, the first terms in each binomial is x. The next term has to be negative because our last term is positive and our middle term is negative. And think of two numbers that multiply to 3, the factors of 3, 1 and 3. And our middle terms will work out to add up to negative 4x, and that's what we want. All right. So if we're solving this, we're not done solving it, we've just factored it. X is equal to 1 and 3. Those are the zeros of these binomials that are in the parentheses. Going to a harder example, number 2. We're going to factor this one also. Similar way. It is equal to 0. We need that. And now we're thinking about two numbers that multiply to 21. 1 and 21. And 3 and 7 are the factors. And at this point, and they're both negatives, at this point, the best thing to do is sort of a guess and check thing where you go try 3 and 7, and then you just figure out the middle terms. The middle term here would be negative 14x, and that would be negative 3x. Put them together, and you get negative 17x, which is what you wanted in the first place. So job well done. We just have to solve it. There's going to be two answers. Clearly this answer is 7. Everybody gets that one. But the other answer is the answer to this problem on the sideline. When does 2x minus 3 equal 0? And the answer is at 3/2, or 1 1/2. In pre-calc, we almost always leave our fractions as improper fractions. We don't convert them to decimals very often. So our two answers are 3/2 and 7. Final problem is to solve this. And you can see we got the quadratic formula to the side. First off, we have to set everything equal to 0. So I'm going to subtract 6 on left and right. We set it equal to 0 so that, for a couple of reasons, the main reason in this case is so the quadratic formula will work out, because we need to start with it all equal to 0. And x is equal to the opposite of b, that's 5, plus or minus square root of negative 5 squared, which is positive 25, minus 4 times 1 times negative 10. I'll put it in parentheses, extend that, all over 2 times a. If you're confused, a here is 1, negative 5 is b, c is negative 10. Right in here is where the mistake is often made, right? We oftentimes get the wrong sign there. So let's just be real cautious here. I got x equals 5 plus or minus the square root of, turns out it's 25, minus 4 times 1 times negative 10. Two negatives there, so it's 25 plus 40 is the square root of 65 all over 2. That is your final answer to our final problem. Take care.